Good evening, everyone. This is Unit 2 of IAL Physics, January 2015. In this session, I'll discuss MCQs. The numbers in the table represent regions of electromagnetic spectrum in order from low frequency to high frequency. Which line of the table correctly matches a region of electromagnetic spectrum to its name and application? So the one which is having the highest frequency, that's gamma, and the lowest is a radio. Then it will be micro, infra, visible, ultra, and X-ray. So region 1 is not the gamma, region 3 is infra, that's true, and it can be used in optical fiber, that's also true. Region 5 is not the visible one, and region 7 is gamma, but that is not used in television signals. So B is the right answer. The diagram represents the particle in a medium before sound wave passes through while a sound passes through. Which statement is not? So before wave passes and once the wave passes through the particle as the wave passes, which statement is not true? Because sound waves are longitudinal waves, so particle displacement is parallel to direction of energy transfer, that's true. The wave caused the formation of compression and rarefaction. So in longitudinal wave we have compression and rarefaction. X is the position of maximum particle displacement. X is not the position of maximum particle displacement. You can clearly see that at point X the particle will have minimum displacement, not the maximum displacement. So statement C is not correct. Y is the position of zero particle displacement. At this position Y, particle displacement is 0 because that's a mean position. So this also a true. X is the position of maximum particle displacement, that is not correct. Question 3. The current and the terminal potential V of a cell are measured and the current through a cell is varied. The following graph is which row represents, so we can have this equation that EMF is equals to IR plus V, voltage drop internally plus voltage drop externally. If we are plotting on y-axis, we have voltage, so if I rearrange this equation, V is equals to EMF minus IR, or we can also say V is equals to minus IR plus EMF. So when we compare with the equation of straight line, y is equals to mx plus c. On y-axis, if we have voltage, on x-axis we have current. So our gradient will be minus R, negative internal resistance. So internal resistance is a negative gradient, and y-intercept, that will be the EMF. So when it intersects the y-axis, so EMF is a y-intercept and internal resistance is a negative gradient. So B is the right answer. Question 4. Which of the following is equivalent to single SI base unit? So SI base unit, what are the base units? We have meter, kilogram, ampere, Kelvin, second, and light intensity, candela is there, and unit of amount of substance, mole is there. But for physics we are basically doing for 5. So coulomb per second, that is current, and the unit of the current is ampere. So coulomb per second represent ampere. Joules per coulomb, because voltage is work done per unit charge, so joules per coulomb is representing voltage. Voltage unit is volt. Joule per second, energy in or work done in a unit time, that's equal to power, so that unit is watt. Meter per second, that is equals to speed or velocity. The diagram shows a ray of a light passing from vacuum into a transparent medium. So frequency, it's not a ratio of frequency because the frequency does not change. So it can be a ratio of the speed or it can be a ratio of wavelength. Why not angles here? Because sine of angle of x over sine of angle of y, that's also wrong. Why? Because angle x and angle y are not the incident or the refracted angle. Because the angle of incidence and angle of refraction is always from the normal. So x and y are not from the normal, so it is not a ratio of the angles. So we are left with either C or D. Then because it is traveling in vacuum and move in a medium, and then we know n1 over n2, that refractive index and speed are inversely, higher refractive index, smaller speed. So n1 over n2 is equals to v2 over v1. So refractive index of the medium, refractive index of the vacuum, so we'll take as 1, refractive index of the medium is n, speed in medium divided by speed in vacuum. So we need n when we simplify, so n is equal to speed in vacuum divided by speed in medium. So that's why C is the right answer. Why D is not the right answer? Because medium is written in numerator and vacuum denominator, because when we convert this equation, V is equals to F lambda. So refractive index will be equal to wavelength in a vacuum divided by wavelength in a medium as well. Which of the following would allow detail in ultrasound scan to be increased? So if we want a greater detail, we prefer to use a shorter wavelength. And how we can decrease the wavelength? By increasing the frequency. So by increasing the frequency, it reduces the wavelength, so we'll have more detailed image of the object. The current in wire is I and the drift velocity is V. The wire is replaced with another one with same metal but half the diameter. The current in wire, so current in wire 1 is same as current in wire 2. And current in wire 1, we have the transport equation I is equals to N A V Q. And for wire 2, because it's of same metal, so charge density should be same. What about area? The diameter is half. The relation between area is equals to pi r square, or area is equals to pi d square by 4. So if diameter is divided by 2, area will divide by 4. So area, this will become a by 4, drift velocity in medium 2, say v2, and charge is q. So this q will cancel with q, n will cancel with n, a will cancel with a. So we are left with v1 is equals to 1 by 4 of v2, or 4v1 is equals to v2. And v1 initial speed was v, so we can say 4v is the speed in medium 2. That's why D is the right answer. The diagram shows a circuit containing a fixed resistor and a negative temperature coefficient thermistor. So negative temperature coefficient thermistor means when we increase the temperature, its resistance will decrease. The temperature in the circuit increase. So if the temperature increase, if this is R1 and this one is R2, the total combined resistance of the circuit is R1 plus R2. So as the temperature increase, resistance of thermistor decrease, so R1 plus R2 will also decrease. So total, if the resistance decrease, voltage is kept constant, V is equals to IR. So V over I is equals to R. If voltage is kept constant, resistance decrease, so the current, total current in the circuit will increase. And what about the potential? When we compare potential between X and Y, so because the resistance is less, so less voltage will drop here. In comparison, more voltage will drop across R2. That sum V1 and V2 will be same. The sum of V1 and V2 for any condition will be same. But what is happening? The V1 is decreasing, so V2 should increase. So potential across the thermistor will decrease, where the current in the circuit will increase. So C will be the right answer for question 8. For question 9, the potential of a 15 volt is there. A resistance of fixed resistor is 40 and thermistor is 60. What is the potential between X and Y? So this one is 15. Fixed resistor is 40 ohm. This one is 60. So we'll use the potential divider formula. V1 is equals to R1 over R1 plus R2 into combined voltage V. So resistance of that part divided by sum of the resistance into combined voltage, which is 15. So when we solve this, 60 divided by 100 into 15, 0 will cancel with 0. This will be 3, 2. This will be 3. So 3 multiplied by 3, that's equal to 9 volts. So answer is D. Question 10. In plane polarized light, the oscillation of electric field are. So what is a polarized light? Light which is having a single plane of vibration. So example, if you are representing electric and magnetic, because it's electromagnetic wave, electric and magnetic fields are perpendicular to each other. So when we draw the electric field, the polarized light will have a single plane. That's one thing. And that plane, if this is the direction of the propagation, direction of the wave or energy transfer, so it is in the plane which include the direction of energy transfer. So in a plane polarized light, the oscillation of electric field are in a single plane. Oscillation of a, because they are asking about the plane, so oscillation of electric field are in one plane, and that plane include the direction of energy transfer. So energy transfer in the same direction as the plane. So that's why A is the right answer, because the question is not only polarized light, they're asking in plane polarized light, the oscillation of electric field are in the single plane, and which include the direction of energy transfer. So this was unit 2 from January 2015.